Welcome. So this is Math 347 Bayesian sets, and just so you know, the course is shared across different colleges. So we are recording the lectures real time, and I don't know if anybody's going to join today. Most likely not, but possible that someone's going to speak up, asking a question. So just so you know, and also you notice that at the we also have the camera, like just looking at all of you. I hope everything's fine. Like, okay. All right, sounds good. So typically I try to minimize it so we can have the space looking at the entire video. And those videos going to be uploaded later on to YouTube by sections. So later, if you want to review any of those material, you can see them as well. Okay. All right, I will just get started. And so this is the introduction to the course, and with some review as well. I've done this for a while. All right, yeah, so we're going to do a course orientation for maybe 10 to 15 minutes, and then we're going to start doing some preview, especially how to think about probability in terms of the Bayesian perspective. And then we're going to cover Bayes rules, which is probably something you heard before, but we're going to walk through using a simple example. I will also cover topic 3 here, as you can see here, at Bayesian inference, looking at the general procedure with an in-class exercise just to get everybody up to speed thinking about it. And then I will do it, probably not today, later, maybe Thursday, that we're going to do a little bit of probability review, because that's the main review that I can think of in order to make sure that everybody is up to speed with the course. And the prereq for this, mostly 220, 221, and 241. And I know some of you, I mean, all of math. And maybe some of you have taken, instead of math 241 probability, but econ 209. If that is the case, typically it's fine. I've had students before taking that instead of math 241. But again, I'm trying to give enough review, not only now, but later as well as we go along the way. But if anything like comes up that is just not clear to you, ask questions, do those exercises, and I'm happy to share any other material, especially say from 241. I'm currently teaching it. And if you want to get a more review of that, just let me know. All right, so for the course orientation, I'm Monica Hu. You can call me Professor Hu, and that's my email address. You already saw my emails before. My office is Rocky 403 upstairs on the 4th floor. We meet every Tuesday and Thursday, 1:30 to 2:45 here. And yeah, I think that's probably the only door to get into this room. But anyway, everybody's here. Well, if people were not here, I wouldn't know. Anyway, I assume it's reasonable. So the reason, again, we're using this room because of the ceiling mic, as you can see. So when you guys are speaking, it's going to be pretty well captured using the ceiling mic. So just like when you ask questions, just speak up so we can like record everything overall with good quality. But the classroom setup, as you can see, is pretty tight. And then, so yeah, just come in and then find a seat as you want. And so we also have some labs throughout the semester. We're just going to do it here. Okay, so when we're going to work on labs, I will just announce it beforehand so you can bring a laptop. Okay? And office hours this semester, 4 to 5 on Monday, Wednesdays, and Wednesdays 10:30 to 11:30 and 1:30 to 2:30. Those are like, you don't have to make an appointment, just stop by whenever during those times. And I also have separate online office hour for remote students, which I will talk to you about it soon. We also have 3 grader and TAs for this course who, the 3 of them all took the class last semester, so they're pretty fresh with the material. So I will try to work with them to see if they can hold office hours as well. But on Moodle, I posted their email addresses, so whenever you have questions, feel free to email them as well. So on Moodle, we do have the information. And okay, so I mentioned the prerequisite is multi-linear algebra and probability. And I should mention, I mentioned this soon as well, that it's not required that I'm taking any kind of stats, because that's just how, like, at here, our course structure is like. So only in the first lecture that I'm going to talk a little bit about, like, say, the traditional or frequentist classical inference maybe some of you have exposure before, but other than that, we will never touch upon any kind of comparison or that. But some of you have experienced in that before, for example, in 240, Introduction to Statistics, as well as 242, Applied Statistical Modeling. And if you have taken 341, Statistical Inference, so all of those, mostly about frequentist classical inference. Okay, so if those are great, if not, don't worry about it. I will not require anything from there. We're just gonna, for the entire semester, think as a Bayesian and then work through problems like that. Okay, and the textbook is the first course in Bayesian statistical methods. And yeah, I think yeah, I should get it online or anywhere else. I think there's a soft copy as well, so should be good. And for software, I think many of you have used R and R Studio before. If you have not, just download them through those links. All right, you see, so this is the remote student. I'm just gonna admit, and he's gonna show up. Let's see. Hello, Hoya. Yeah, well, it's all right. Maybe you will take some time to respond anyway. So yeah, occasionally when the remote student is free, I think we'll join the class. Anyway, so if you have not downloaded and installed R and R Studio, just follow those links. Those links are on syllabus as well. And remember, the R Studio is just a friendly interface. You will have to download and install R as well. R is the actual computing software language, right? So do both. If you have questions, just let me know. I can help as well. And the web pages, Vasis Moodle, is your responsibility to check the site for homework, readings, announcements. Also send emails pretty frequently about any kind of announcements. Check the tentative schedule of Google Docs for frequent updates. So just to show you, yeah, I haven't used this for a while. I have to think what I should be doing. Okay. So. Yeah, so this is the tentative schedule that I talked about. I think many of you already took a look already. So basically, we break it into different lectures. So I post one huge lecture slides for the entire topic on Moodle. And then say, for example, today and then on Thursday, we're going to cover like introduction, like what we're doing right now. I already posted, some of you have downloaded before. And yeah, so I highlight them in like by topic or by unit. And then they're assigned readings in this column. So make sure you attempt them. Those assigned readings are on the book. And whatever is due, I try to make sure that they're all included here as well. So this is the tentative schedule. You can always access it from Moodle. So if you go to our page, it's going to be here. Okay? Yeah. So but most of the important things I will always send out an email to announce. But this will be a good page to go to whenever you are not sure what is due or whatever you have to do. So this will be my recommendation for you to check pretty frequently. And all right, just all right. Okay, so that's for the webpage and the course topics. So overall, just want to give you an overview of how the class is divided into 3 parts. So for Bayesian statistics, we try to focus on 3, at least in this course, 3 general parts. The first part is inference. So that includes like Bayes' rule, which we're going to cover later today. And the specific details of, like, say, what is the prior distribution, what is the posterior distribution, and all that, and predictive distribution. They are what we call into the inference part, and they are corresponding to those chapters in the textbook that I list over here. And so we're going to build up from here to start with, because you need to know the basics. Here is mostly like a little bit math, trying to derive and then make sure that you understand why things work. But then soon we will have to move to computation, because Bayesian inference relies on computation a lot. Because most of the simple models, like what I put over here, conjugate prior, is kind of, We're going to cover this soon, but those are like distributions or prior distribution in the models, which have like analytic solution pretty straightforwardly, but most of the more complicated models would never have them. So we have to rely on computation, in particular simulation, to do the inference for the Bayesian method. Okay, so we're going to cover Monte Carlo approximation, which is corresponding to half chapter 4. But more importantly, we're going to cover what we call MCMC. Maybe you heard the term before. Stands for Markov chain Monte Carlo. And it's a whole class of algorithms that we can do. But specifically, we're going to cover Gibbs sampler here, Metropolis Hastings, and then we're going to cover how to do diagnostics for those algorithms. So those are the key building blocks to any of the advanced material, any advanced models that we're going to cover. So we're going to, I'm hoping, say, for example, Monte Carlo approximation, we're going to cover actually starting from the second lecture, but then we'll have to go a little bit more before we can go to MCMC. But at the end of the day, you will see that we're going to rely on what we call JAX. It stands for just another Gibbs sampler. It's our package that like you download, it's a software, but there's our package to call it. So we typically going to use it, especially for more advanced models, to use this, to rely on this to implement those MCMC techniques. So JAX is not covering the textbook, so I'm going to provide more additional material to do that. In short, you can always write your MCMC, what we call those sampler, but it requires a lot of work in a sense that you have to know exactly what the distribution is. You have to derive them carefully, okay? But of course, for practice, a lot of people would never do that in a sense that those models can get super complicated. And for practitioners, people develop things like JAX, and there are also bots. There are all kinds of words that they are just standalone software, but then with our packages, people can implement those Bayesian methods pretty easily. Okay, so for us, I want us to understand the basics of MCMC, but then moving, say, halfway through for the second half of the semester, we're going to rely on JAX to actually learn those models, because otherwise we're going to be stuck trying to derive all different kinds of models and then how to write your own Gibbs sampler or MCMC. So JAX will be a super useful software there. Okay? But of course, in order to write the correct JAX model, you still have to understand the model first. Okay? So those will be coming from the previous lectures like inference and then the other basic computations. So this is the second part. And the third part is applications. So of course, throughout, we're going to, except for the beginning few lectures about those conjugate prior, we're using some toy example. But later on, we try to use real world examples in the sense that trying to solve those problems using, for example, Bayesian hierarchical modeling and linear regression from the Bayesian perspective, et cetera, et cetera. So those, some chapters are covered based on this, but I'll also provide some additional material throughout. Okay? So, so these are the three parts that I think it's maybe, like, at least from my side, from the teaching side, I think it's important to differentiate and put them like together so we can have a bigger, like a whole picture of the whole course. But for you, I think, yeah, even at the end, I think everything will be worked together. Like say, this is, you cannot say this is just inference, it's just computation, because everything going to depend from each other. And then in order to solve a problem, especially later, you will have to do a course project. To build up your course project, it's going to be combinations of all kinds of things. Okay, so just keep in mind, but we do try to emphasize a lot of computation for this course, in a sense that everything's going to be done through R. We're going to cover the basics, but then we're going to move to what I call JAX and other softwares that can do those for you. Okay? So you can think of them as like software to empower you to do more advanced models. And if you have taken other stats courses, any kind of, like, say, when you run a linear regression, when you write LM, that's a software behind. Okay, so JAX or like Bayesian methods just requires more understanding before you can even get there. And in order to write the models, we have to understand how the model works and why we want to write the models in the first place. Okay, so JAX itself, as you will see later, it's pretty straightforward. So as long as you understand what you want to do, JAX can do that for you. All right, and yeah, so that's what I mean at the end, no strict boundaries between topics, that depend on each other. And I hope along the way you will be able to gain this perception of, well, when you are doing Bayesian analysis, it's really all kinds of stuffs together. Okay, we break them here for instruction purpose, but when you do analysis, it's a combination of all of them. All right, and then really quick on this. So earlier I mentioned that we do share this course across a consortium. It's called Liberal Arts Collaborative for Digital Learning. And this is under the course share project. So we're trying to enrich upper level math stats offering across 10 different liberal arts colleges. So this semester, I don't think anyone in this class is taking Professor Steve Miller's operations research course. But I think we do have 7 Vassar students like taking advantage of this shared network, and they're taking Professor Miller's operations research now. Yeah, so if any of you is interested, let me know. I can put you guys in touch. But at the same time, well, we have those Bayesian stats being shared for this semester. And so for just a little history of what we've been doing, ever since the course is being on the network. So we started in fall 2017. At that time, 16 master students and 1 Swarthmore. Last semester, we have 16 from Vassar, and then 1 from Amherst, 1 from Carleton, 4 from Swarthmore. So that worked out really great. Currently, I think we have more than 16 now. I made the slides before, like all of the ads and stuff. I think close to 20 Vassar students, and then we get 1 from Amherst and 1 from Swarthmore. And Ho Ye, who is, I believe, listening to us right now, is from Swarthmore. So overall lectures, so for Vassar students, nothing has changed. You guys come here. I'm just recording and then actually can give you the flexibility if you ever want to watch those videos later on. I'll share some comments about that in a minute. So what we do is lectures will be synchronized online real time, like Hoya can join now, but it's also going to be recorded and then uploaded on YouTube for remote students. And we have separate online office hours for those remote students. And I definitely encourage group work across campuses. So throughout, we will have some case studies, and then in the end, those projects. I really encourage you to, reach out to remote students. Well, you might, say, for example, from the self-introduction post that you make on Moodle, if you find that the remote student actually share interesting or interest of the projects with you, feel free to reach out, and we can actually start working early. So there's that. And I asked you to fill out a pre-course survey. So there are 2 surveys that ask you. One of them is what I call pre-course survey. That's just anonymous, just asking you about your experience of hybrid learning. And I will post another one at the end of the semester. So please fill that out. Just want to get some information from you all. And so my experience is some learning materials suitable for video form. Later in the semester, you will see that instead of inviting a professor to come here to give a guest lecture about Bayesian hierarchical modeling, we have recorded a video so you can watch it beforehand. And then we try to weave that into all of the learning experience. And say on Moodle, we're going to have discussion forums. So I'll ask you to watch the video, make a post, and then we have a discussion based on the post that you guys make beforehand. Okay, and then afterwards, maybe another post, things like that. And also some recaps and our demonstration. I think I found them pretty useful whenever I turn them into short videos so people can make use of them. So we're going to try to keep doing that. And Moodle discussion forum is a great way to make everybody involved in the learning community. So we're going to use that as well. And that's part of the participation. So I will give instruction when we come to that. And from my experience, that we should have more interaction among Vassar students and remote students. So we're going to do more interaction, hopefully, with like case studies and projects. And lastly, I also wish to have more interaction among Vassar students. The last semester, everybody just sat at the same place, like throughout, which helps me to know everybody's faces with the name, so that helps. But I do want to make sure that, so we meet we meet twice a week. Okay, so my only request is that every week for those 2 days, just stick with a different neighbor. Okay, so I won't keep track. I mean, it's hard to keep track. Just follow that. Like, just walk, maybe like choose a different row. Sit with a different person. We're gonna have some in-class discussion and stuff. So yeah, hopefully you get more interaction and more perspective from people with different backgrounds and experience. All right, so what I did, so remember I asked you to do a post-course survey, like remember to do that. So I used to do it as well. So I do get some feedback and advice from those anonymous surveys. So I thought it would be fun to share. So these ones, the 4 that I put it over here, is, yeah, just overall. So let me just go through it really quick. So the first one, obviously, I think is from a remote student. For this case, unfortunately, I think only one from each school, so it's going to be a little bit harder for them. But like you can see from the second, if you're a local student, it will not make a big difference. So I don't know what is a big difference, but you will see how things play out. But I also want to mention that the third comment here, rewatch the YouTube lecture videos, go to office hours, and get an early start on the project. I think it's from a local student. So I noticed that people do when they try to review and then relearn or like catch up with things, you can watch the videos multiple times. Okay. And one thing I do want to mention, the only one comment which I want to address here. So this last comment, the textbook was very different than in-class lectures. So again, the book is at a graduate level. There are very few undergrad level Bayesian textbooks out there. And I got my first Bayesian education out of this book. So I overall liked it, but I have to say many of the stuff might be a little bit too complicated at the undergrad level. So that's why, so I still encourage you to get a copy of the textbook and read it through and or borrow from your friends. But you will see the in-class lecture as well as the homework and all that will be quite different because I want to involve more, say, just for example, like JAX, the software that I mentioned, it's never used in this book. I think it's really useful to cover at the undergrad level so you guys can try more complicated, interesting models, even in the first course. So that's just a quick example, but there are many other things different between what we cover in the book, what we cover in the class with the book. But again, I'm glad that someone made the comment and I decided definitely, I included all the comments by the way, but this one I do want to mention that you will find it different, but you're still gonna learn stuff from this book. Okay? So just be prepared. And one other thing, well, this is long, I don't think I will read it all that, but I did ask one question. Do you rewatch the lecture video or lecture recordings? How often, for whatever reason? I think overall, so in the parentheses, I just put down whether the student is from Vassar or remote. So overall, I think people do watch them or rewatch them, even though they attend the lecture. And what I'm trying to do is all of the videos going to be broken into topics. So right now we're under like course orientation. So later on YouTube, you will just see like course orientation. So this one, I don't know, maybe 20 minutes. So that will be a particular 20 minutes video. And then later for every, say, soon we're going to do probability review as the topic. So it's going to be a whole video just for that. So Zoom, the software that I'm using, allows us to break it automatically whenever I like stop recording and start recording again. So I found that feature pretty useful. And yeah, so the slides is posted online, so I wouldn't read them here, but just so you know, I think many people do find using other than just like reading or like doing exercises, but also trying to rewatch those videos might help your understanding overall as well. Okay, so the 3 parts I mentioned, inference, computation, applications, and of course, all the time we probably have to do some reviews. So I will try my best as much as I can. And at the beginning, we will do a probability review, but along the way, you will see a little review here and there as well. So yeah, just in general, ask questions whenever you have them. And each part will be a combination of a selection of following, some readings from the textbook, lectures, we do labs, homework assignments, discussions, so both in class and online on Moodle, and trying to add in case study as much as we can and the final project here. Okay, so these are the general structure. And the course project, I do want to mention this early on because this is a very important component of this course. You can do it individually or in pair, and you can do it across campus. It's highly encouraged. It's a final product involving inference computation applications. What I do is you can choose whatever topic you like, and I actually ask you try to mention what your interests are on the self-introduction post. So I encourage you to read through and then maybe pair up as soon as you can. I do want to, like, say, have this project in mind along the semester so you can keep building up, like adding a little bit more as the semester goes on. And try, like, post your self-interest, self-introduction, and then show your interest and reach out to whoever you think you might be working with. And when I say, like, it's totally up to you, you can find a paper to read and then try to implement the methods that they cover. that's totally fine. If you, from your internship, your other courses, that you have a really interesting statistical analysis problems I can think of, but you never did it in the Bayesian way, you can do that. And along the semester, you will see that we're going to cover certain applications, so that might generate some ideas, okay? But overall, I still think that, especially if you're doing like applied work, like trying to do in a particular specific domain, I will highly recommend you start looking for data sets and frame your question early on, because the methods, or like the actual statistical methods, we're going to learn along the way. But then if you already have an idea early on, and then search for the data set early on, I think that can help you a lot. Otherwise, you might cram a lot at the end. Okay? But I mean, again, that's true for a lot of course projects, especially in the statistics course. But I would recommend you to start early on. And basically, you're going to apply the Bayesian methods you learn in this course, or explore new Bayesian methods to solve research questions of your choice. And you will see that I will ask you to do a poster session at the end of the semester. So it's going to be a last lecture meeting. We're not going to meet here. We're going to meet in Rocky, a bigger classroom. So we're going to have a poster session there. I also asked you to do a 2-minute intro video. And just so you know, what kind of, so those are good products, but they're not the only good ones. I couldn't include all of them, but I do want to share a little bit with you, especially from last semester. We, every time we had this 2-minute intro video that we recorded. So I'm thinking maybe we can play a few of them. Let me see how this can work. So, yeah, let me think how I can do it. Yeah, I never tried from Zoom doing watching a video before, so. All right, so what I will do, give me a second. All right, so the first one, if I remember it, let's watch this one. No, we couldn't hear anything, right? Okay. Give me a second. Yeah, this is always the awkward part. So let me. Share. Okay. So this is the first one. It's called Bayes by Backdrop on Weight Uncertainty Neural Networks. I should mention the 2 students worked on this. They read a paper first, okay, and then found, so the methods is pretty complicated, and what they did is I think they found online tutorial in Python, how to implement those models. So they replicate what's done in the paper and then found a different data set and try to implement it, okay?
In neural networks that enable them to learn such complex tasks.
For our project, we compared 3 neural network models. In the first model that we investigated, we used a standard learning algorithm called stochastic gradient descent, which adjusts the weights in a standard neural network proportionally to the difference between the network's prediction and the actual desired output. The approach that researchers have taken to prevent overfitting is using a training method called dropout. This method essentially uses the same algorithm as stochastic gradient descent to update the network's weights. But the difference is that during each round of updating, the algorithm will randomly drop or ignore some proportion of the network's weights. This is the second neural network model that we looked at. Finally, we compared these 2 methods to an approach that uses Bayesian inference to help prevent overfitting. This approach is called Bayes by Backdrop. Where typically a neural network defined over a weight is acting as a prior distribution. The performance of the neural network is acting as the collected data, and then Bayesian inference is used to find posterior distributions for each weight in the network. Using this method, we found Gaussian posterior distributions for the weights of the network that we trained.
First data set was data set of 10 images. Second data set was images from objects categories.
We supplied rasterized PNG images of the digits and the objects as input to these networks. And the goal of the networks was to map the image transfer boundaries of these images to the correct class of either digit or real world object.
So that's the first one. So if you don't know much about what they're talking about, it's totally fine. And but you might be able to do. I mean, not exactly the same one, of course, but again, this one, these two students, I think one of them is from Cox Sci. It's a double major there, I think. So like he already worked on a lot of related stuff. So he brought together those two topics. So that's an example. I mean, it's a great project, but I'm not saying that you have to do like following like the same structure or anything, just to give you a flavor. And there are two others I want to show. This one is Bayesian word embeddings. So those are students, I think, mostly from computer science, and who's trying to do more natural language processing related project using the Bayesian models. So just really quick here.
Hello everyone, this is a natural language processing group, and for our project, we decided to investigate Bayesian word embeddings. Our research question was comparing the Bayesian skip-gram version of Word2Vec with the standard Word2Vec algorithm and analyzing the results. And according to the results presented in Brzezinski et al., the Bayesian skip-gram seems to have an advantage over the standard Word2Vec algorithm. So we implemented both the code found in the paper and our own version of Word2Vec and compared the results. A bit of background on what the Bayesian skip-gram Word2Vec algorithm allows users to do is to generate posterior distributions given a prior distribution and context. So if the unshaded regions are the prior distribution of the word king, then given viewing the context of bird, king will become a posterior distribution. This is also seen here where the Bayesian skip-gram encoder takes in the word and the surrounding context of the word and returns substitutions. So even though they're the same word, the context is different, which will result in different substitutions. And all these embeddings can be visualized using Google's projector, TensorFlow projector, which we have here 10,000 words visualized. And if we click on a word, we can see most similar words to a given word. The conclusions of our research is that due to the lack of computational power and different methods of preprocessing, our results weren't as strong as the paper, but the Bayesian skip-gram model is still comparable to the Word2Vec model in terms of similar words and processing
Right. Okay, so that one, the Bayesian word embedding. So like what they said in the video, computation requirement is really high. And but I think computer science students have a particular account. Yeah. Anyway, so you can figure out if you want to do something like that. And I also want to mention that particular project. We have two bachelor students and one from Carleton, and I think they worked on together pretty well. So just again, encourage you to reach out to remote students. And this one is from Dahlia. She did her project alone, and this one is more traditional in a sense as trying to do a regression type of analysis. Okay, but she went online to find different data sources, try to she had a research question first, and then tried to find out the appropriate data sets, and then how Bayesian regression can help her explain and solve the research question.
About income inequality among people with different sexual identities. Unlike the gender wage gap, which has been thoroughly explored in both differences and Bayesian techniques, the income differences between people of different sexual orientations has been relatively unseen. The bigger trend is very limited. own incomes throughout their lives. Meanwhile, the Fox, Roman, and Rui in 2009 came up with more nuanced and complicated results. They found that some groups within the lesbian, gay, bisexual community are actually predicted to earn more than their straight counterparts, such as married lesbian. On the other end of the spectrum, they found that some members of this community are predicted to suffer the worst labor market outcomes of all, like bisexual men and bisexual women. My work focuses on Bayesian linear regression to emphasize these income disparities and to motivate other researchers to explore these differences as well and expand the current literature of labor economics. The three data sources I used to do so both come from the Integrated Public Use Record Data Series. That is the 2017 American Community Survey. Bisexuals restricted to only 5,000 married individuals because they have a variable in their survey of same-sex marriage couple that equals 1 if the individual question is a part of the same-sex married couple and 0 otherwise. It's not fair to look at only gay married people or people in same-sex married couples and people who are heterosexual and unmarried, because marriage covers higher wages throughout your life. The second data source that I use is the 2017 National Health Interview Survey, which asks straight up about an individual's sexual orientation. The categories include I'm not sure, uncertain, etc. So I just looked to people who responded gay or lesbian, bisexual, or straight, that is not gay and not bisexual.
Hello, everybody. My name is Tyler, and I'm part of Isaac tonight.
All right, so yeah, so there are different ways to craft this 2-minute intro video, and I will give more instruction later, but for now, I just want to give you a sense of what a final project will look like, and hopefully you get some idea. But again, you have to start figuring out what kind of questions you want to do, and then say if you're doing something like what Dahlia did, then you will have to find a particular correct, or I would say like appropriate data sets for you to answer those questions. In class, we're going to cover methodology using examples that I can find, but of course, everybody has different interests, so I wouldn't. Yeah, anyway, so there's just some sample projects, and in the slides, I included the list of all of the projects. So if you follow the link, want to see what other people have done, feel free to do so. And yeah, the slides is on Moodle, so just feel free. And yeah, so maybe just any questions or ideas that you want to discuss and share about projects. I mean, I asked you to do it on Moodle self-introduction, but for now we can break really quick. You can talk to your neighbors a little bit about what kind of yeah, like research questions you have or interests that you have, and then we just, if you want to share to the whole class, feel free as well. So it's gonna break really quick for like 1 or 2 minutes. Anyone who wants to share your ideas, like to say what kind of material you want to get out of this class, or in particular what kind of course project ideas that you have. I'm going to read through all of the Moodle posts, of course, but now maybe if you want. It's not binding, so it's not that like I'm going to remember and go back to this video and say, oh, you said that you could do that. Anyone? Yeah, Josh?
It might change over time, but I was thinking of doing some project related to recommendation systems. So there's a lot of hype about how you can apply Bayesian statistics to recommendation systems. I want to see if that performs better than traditional ones.
And that's related, sort of related to your summer internship, right?
It turned out to be different, but yeah, I'm still interested in doing it. Yeah.
Cool. Anybody else? right? It's okay. So what I would do is I would read through those posts and I would just create a Google Doc, like categorize in case, like put like topics, and then you can sign up. I'm just hoping that y'all can start working on the project early on, because it's going to be pretty demanding along the way. Okay. All right, lastly, just the grading. We have 25% for homework and labs. Participation both in class and online is 10%. There's no final, but we have 2 midterm exams, both of them 20%, and the project is 25%. Okay, so no final, so we're going to end last day of the class. And what I listed here is also in the syllabus, just the rough range of how the numerical final is going to turn into a letter grade. All right, so for you to do, make sure that you finish the class survey, which is just getting information from you, so I know you a little bit better, and then the anonymous pre-course survey. And those, the links are on Moodle. And we're also going to use DataCamp, which is the online learning platform, to make sure that we are all up to speed with all of the R programming. So I put 2, the first 2, Introduction to R and Intermediate R. I put them in parentheses because many of you might have experience of it already, so I do not require this too. But I assign them, so if you want to finish, just to try to make sure that you know all of them, feel free to do so. But the third one here, Introduction to the Tidyverse, it is required. The hours, it's just like how long in total it's going to take based on, because DataCamp is like people pay for it, and then well, for us it's free because it's classroom use. But just so you know, DataCamp is an online learning platform that people try to gear up with certain programming stuff. So they do like make sure that it's within certain hours that someone can finish this course. So I put this here, and all of them are due. In fact, only the third one is due, but if you want to do any others, feel free. And I'm still in the process of like creating the course group for us. So once I hear back, I will email everybody so you can get into the DataCamp Math 347 group, and then you will see those assignments there for you. Okay. If it's going to take too long to do it, I will set the deadline a little bit later. Okay. All right, and of course, make a self-introduction post and try to read others' posts, especially for common project interests. Get the textbook, read chapter 1 and chapter 2, and then download and install all the courses. So this is to do, I'm sure some of you already did some of this. This is great. But after class, if you can do it as soon as you can, that would be great. So this is, of course, orientation. So what I would do is that